In this video, we will talk about section 1.2 in the book, types of data. A parameter is a numerical measurement describing some characteristic of a population. A statistic is a numerical measurement describing some characteristic of a sample. The alliteration in population parameter and sample statistic helps us remember the meanings of these terms. For example, there are 17,246,372 high school students in the United States. In a study of 8,505 US high school students 16 years of age or older, 44.5% of them said they texted while driving at least once during the previous 30 days. Parameter. The population size of 17,246,372 high school students is a parameter because it is the entire population of all high school students in the United States. If we somehow knew the percentage of all 17,246,372 high school students who reported they had texted while driving, that percentage would also be a parameter. Statistic. The sample size of 8,505 surveyed high school students is a statistic because it is based on a sample, not the entire population of all high school students in the United States. The value of 44.5% is another statistic because it is also based on the sample, not on the entire population. Also, don't text and drive. Quantitative or numerical data consist of numbers representing counts or measurements. Categorical or qualitative or attribute data consist of names or labels, not numbers that represent counts or measurements. Categorical data are sometimes coded with numbers, with those numbers replacing names. Although such numbers might appear to be quantitative, they are actually categorical data. With quantitative data, it is important to use the appropriate units of measure, such as dollars, hours, feet, or meters. We should carefully observe information given about the units of measurement, such as all amounts are in thousands of dollars, or all units are in kilograms. Ignoring such units of measurement can be very costly. NASA lost its $125 million Mars Climate Orbiter when the orbiter crashed because the controlling software had acceleration data in English units, but they were incorrectly assumed to be in metric units. Quantitative data could be the ages in years of subjects enrolled in a clinical trial. Categorical data as labels, the genders, male or female, of subjects enrolled in that clinical trial, and a categorical data as numbers, the identification numbers 1, 2, 3 through 25 are assigned randomly to the 25 subjects in a clinical trial. Those numbers are substitutes for names. They don't measure or count anything, so they are categorical data. Discrete data result when the data values are quantitative and the numbers of value is finite or countable. A set of data is countable if it is possible to count the data individually, such as the numbers of tosses of a coin before getting tails. Continuous or numerical data result from infinitely many possible quantitative values, where the collection of values is not countable. That is, it is impossible to count the individual items because at least some of them are on a continuous scale, such as the lengths of distances from 0 centimeters to 12 centimeters. Consider the difference between a mercury thermometer and an electronic thermometer. The mercury thermometer has an infinite number of readings because the fluid expands and contracts to every possible value on its scale, say 90 degrees to 108 degrees. We can achieve any value on that scale, even irrational ones like 90 plus the square root of 2 or 100 minus pi. These values are not countable. However, the electronic thermometer might read the same range of temperatures, but it only returns tenths of a degree. It could return a value of 91.4 degrees, which is pretty close to 90 plus the square root of 2, but it could not return 90 plus the square root of 2 itself. The values returned by the electronic thermometer are both finite and countable. We classify data into 4 levels of measurement: nominal, ordinal, interval, and ratio. When applying statistics to real problems, the level of measurement of the data helps us to decide which procedure to use. Don't do computations and don't use statistical methods that are not appropriate for the data. The ratio level of measurement, there's a natural zero starting point and ratios make sense. For example, heights, lengths, distances, and volumes. The interval level, differences are meaningful, but there is no natural zero starting point and ratios are meaningless. For example, body temperatures. Ordinal, data can be arranged in order, but differences either can't be found or are meaningless. For example, military rank or college rankings. And nominal, categories only. Data cannot be arranged in order. For example, eye colors. The differences between interval and ratio levels of measurement can be tricky. These tools can help clarify the differences. The ratio test, the term twice, describes the ratio of one value to be double the other value. To distinguish between the interval and ratio levels of measurement, use a ratio test by asking if the use of the term twice makes sense. True zero. For ratios to make sense, there must be a value of true zero, where the value of zero indicates that none of the quantity is present, and zero is not simply an arbitrary value on a scale. Frequently, in the case of temperature, neither the ratio test nor the concept of true zero applies. The value of zero on the Fahrenheit and Celsius scales is chosen arbitrarily, and thus a temperature of 10 degrees is not double a temperature of 5 degrees. Fahrenheit and Celsius are interval scales of measurement. The Kelvin scale, which starts at absolute zero, defined to be the temperature at which all motion ceases, is a ratio scale.